Okay. Hello. Can everyone hear me? I should put this chat somewhere better. Pop out chat. Chat put maybe here. And then I might put this here. Okay. Code can go here. This can go here. Maybe I don't even need this. Alrighty. You can hear me. That's good. It's so cold in Sydney. I've got the sniffles from the temperature. Yeah. Last week I was in London. It's the first time ever I've thought London has good weather. But at least we're not in Melbourne, where it's even colder. Okay. It's so different hearing your normal voice speed. What do you normally hear? Do you just like play it on 2-speed? Okay. What's going on here? Let's do this. Okay. Can I center the microphone? Yeah, I see that it's coming. One channel is higher, but I don't think I like. If anyone can tell me how to fix that. Properties. Filters? I'm not sure. Like I'm speaking right into the middle of it. And even if I move around, it's... But I do see the two channels are different. So if anyone's got any ideas, let me know. Yeah. How do I fix that? Do we have some AV nerds in here? Properties? You can pan the audio mix. I don't know if you can do that in OBS. Yeah, how do I do that? Like if someone Googles it and tells me how to fix it, I'll fix it. No, it doesn't have to be stereo. That's a great point. But like, I don't even know how to do that. Oh wait, balance. Hold on. Road mic. How about this? How's that? He's good. Okay. All right. Shall we get to it? Okay. All right. Can you see my slides? Yeah. This is important. So this is the census date for this term. So do we all know what census means? You should, I guess most of you are in T2. So census dates are really important. It's the final date in which you can change your enrollments for the term without financial or academic penalty. So basically, if you're thinking this course is not for me, maybe you need to take it in another term, something like that. This is the last date in which... Oh, my camera's a bit off. Anyway, this is the last date in which you can unenroll. So please, if you're going to unenroll from this course, which I don't want you to, but if you are going to, please unenroll before that deadline. That's Sydney time. Yeah, Bree has just sent a link in the chat with more information. If you've got any questions about census, please contact me. Or you can ask in the chat even, and Bree or I can answer. This is really important. Okay? Yes? I'll continue. Send me a thumbs up if you're good. Okay. Let's do a quick recap of functions and procedures from yesterday's lecture. Now, thank you there's like 150 or 180 items of feedback in the lecture, feedback QR codes, and I do read them. And I try and adjust a little bit based off what I read. So, can everyone still hear me? The chat's just gone a bit quiet. But I'm going to assume it's okay. I'm not seeing any warning signs. Yes, you can hear me. Good. Good. Okay. I need the chat feedback, guys. Otherwise I get please spam. Otherwise I get worried that something's broken. Okay. So yeah, I read all the lecture feedback, which is a blessing and a curse, honestly, because some of the feedback was like, oh, we're taking too slow and the demos are too simple. And then I tried to do something a bit more yesterday, and then I got feedback that it was too in-depth. But it's fine. Like, that's my problem, not yours. But do keep the feedback coming. And I think the problem sometimes is that people don't give feedback when everything's okay. And so I only see things that I try to respond to. So I'm going to do a quick recap of functions, and I'm just going to do a really quick demo of a more simple example of a function to just drive it home a bit more simply. But really simply, functions are reusable blocks of code. It's this idea that some functionality that we can develop is useful more than once. And so we want to be able to name that block of code and be able to repeat that, invocation, call that multiple times. And they are self-contained and isolated. So this point is really important. Because like the local scope, so the variables that are created within a function, once the function ends, they're destroyed. And so that means we get this reusable state that makes it more easy to manage our functions. And so functions are really, really important building blocks of our programs. So here's this is kind of a bad example, but here's an example of a function that does something. In this case, it actually uses arithmetic to calculate an approximation of pi. And you can imagine that if every time you needed to use pi, you needed to write these like 6 or so lines of code, that would be really annoying. So we can package it up into a function that we can reuse. Now, the reason this is a bad example is because you could just type out the digits of pi, but you get the idea, right? So there could be some other thing that's just has to be calculated. Maybe it's got an input. And so we package it up into a function. And if we look at the building blocks here, it returns a double. So this is a function that returns a double. So a double floating point, a number, a numerical value. It's named pi. That's the label that we give this function. It's got no input, so it's an empty set of braces. And then here's the stuff that lives within the scope of the function and that executes when we call this function. And so I think some people had some confusion yesterday because the functions that we wrote returned an enum, which is fair enough. So this is an example where we're returning a simpler data type. And in this case, we're returning a double. So all that matters here is that there's a type that gets returned by the function. And when we have a return statement, what returns has to be the type of the return type. So 4.0 times sum is going to be a double floating point value, and that is going to match the return type. So these types should match. And as Sushi has just mentioned in the chat, you can put void in the brackets to signify that there is no input. I think for the style guide, and Brianna can confirm, that we do recommend it, but it's not necessary. And typically it's not typical. So in industry, I don't think you typically see void, but I've never actually worked in a big C shop in industry, so I can't really say that. You have to put void in this course. Okay, put void in. Okay, there should be void here, per the style guide. Okay. Yeah, I'm not going to talk about for loops today, but I will introduce them at some point. Where would you specify the DP of the return? What's DP mean? DP. Someone has to clarify. Limes, clarify. Yeah. So while that's coming, decimal place. You can't specify the decimal place of a return. The only time you control the decimal place of a double is when you're printing it. You can control how many gets printed, but you can't do that. Like, it doesn't make a double data type. You can't control the decimal places because it's part of the data type itself. Okay. All right. Let's not get too carried away on that though. Why can't we put return void if we don't want to return? I think you actually could, by the way, but it's just inferred that you just have a return statement with nothing, and then that is void. All right. And then another really important point about functions, and especially functions within this program, within this course, is that we need to forward declare our function. So in this example, the pi function is defined after it's used. So here is it's used, but it's defined later. And the way C programs are understood by the compiler is line by line from the top down. That's different from how they're run. They're run starting at main, but when they're compiled, it's top down. And so in this example, it gets to this line 3, and it goes, hold on, I've not seen this pi function, that's a problem. So the solution is to forward declare, right, the function signature. And so what this says is, hey, I promise Mr. Compiler or Mrs. Compiler that there will be a pi function at some point in this program, trust me. And so now when we get to this line, there's no problem. And once the program is compiled, the pi function will exist. So we always forward declare in this course. Yeah, we always forward declare. What does the plus do before the equal sign? Plus before the equal sign. Oh, here? This is a shorthand syntax that says sum is assigned the value of sum plus what's on the right. So it's a increment, not increment, but it adds the expression to the value that was already stored in sum. Yeah, and Brianna's typed out exactly what it actually is. You don't need to worry about, I've done a few little things in here that we haven't covered. The point is that it's abstracted. Okay, so we forward declare. All right, let's just jump back to my code. And the way I'm going to do that is go here, and then this is going to be here, and then this is going to be Visual Studio Code. Oh, it's actually just called code. That explains it. That's too big. I'm going to do it like this. And I'm going to do that. And then I'm just going to do that. There we go. Can you see that, or is it too small? Let me know. I guess I can just zoom that in a bit. So I just wanted to open up this file from yesterday. Let me know if it's too small still. And I'm not in Tiger VNC anymore. I'm using Visual Studio Code and SSHing in. So in this program, I'll make it one bigger. In this program, I think maybe there was some confusion because the functions that we wrote, like get weekday, print weekday, well, mostly get weekday, returned an enum weekday type. So like, let's just write a simpler function that returns an integer. And what this is going to do is I'm going to just be unrelated to the weekday stuff. This is just going to be get, my number. We can say there's no parameters. So this is a function that returns an int. It's just called get a number. Like, it doesn't really matter what it's doing. And in this function, there can be a sequence of steps. So we can say int result is equal to the number 5. We can say like 5, there's that operator again, the plus equals. So what that means is, that should be result. So what that means is whatever the value of result is, add 5 to it and store it back in 5. So this is going to be 10. Then we can return result. Remember, we need to forward declare this function. So that way we can call it in main. So we go to main, we print the weekday. Then we can also printf %d \n, comma, the result of calling get my number. So this is pretty cool. So it's actually calling the function, getting the result of the function, and putting that straight into the printf statement. So if I open my terminal, I compile my program out to a program called program, and I've got an error. So line 34, I'm missing a semicolon. I believe it. Yeah, there it is. So I read the error. I'll recompile. No error. Yes, there's still an error. Oh, I know what it is. I renamed these, so I need to do that. So that's got to be like that. That's got to be like that. Okay, I recompile. There we go. There's that warning from yesterday that's okay to ignore. I say, let's get the day 3, Thursday, and then we get that 10 printed out. If we're defining the function before main, do we need to declare it separately as well? Technically, no, but it's easier just to forward declare all your functions. That way, if you need to reorder things later, especially in larger programs like the assignments, you don't get stuck. So it's just good practice to just always forward declare. So here's an example of a simpler function that returns a simpler data type. In this example, we returned the enum weekday data type. But I do understand that I guess because enums were meant to be introduced in week 2, but because we didn't get to them, I introduced enums and functions on the same day. So maybe this was a little rough. So anyway, that's why I just wanted to write this. Okay. Let's get going. All right. Let's take a moment. So this is a topic called arrays. It's a new topic, a new concept. And it's important. Everything we do is important, but it's important because this is one of the 2 major hurdle topics of this course. So if there's any 2 points in the course in which you're going to pay attention, it should be this and the other hurdle topic. All right? Are you forewarned? Are we feeling good? Can I show the main function again? You can get my code. Bree is going to post the link to my live code, Carson. So I go and read it. If you ever want to look at my code, remember it's all live synced to the course website. So you can always go to refer to every single program that I write each week. It's separated week by week. So you go and grab it there. I don't want to keep jumping back and forth between topics. All right, so arrays. The other hurdle topic is linked lists, which we'll talk maybe a tiny bit about today, but this is about arrays. So we're going to talk about arrays, okay? We all feeling good? Give me a thumbs up in the chat if we're feeling up for it. Yes? Okay, we feel ready and good. We love comp, that's good. Thumbs. All right. Okay. So let's talk about variables. Variables are the way in which we can store data of a particular data type into a piece of memory of our program. I need an arrays. Yeah, absolutely. So variables are the way we store data. And so far, each variable we create of a particular data type, we can store a single element of that data type in memory. Yeah? So hopefully that's making sense. So if I've got an integer called my age, I can store a single integer value, 32 bits, in that integer. But what if we want to store multiple values of the same type? So, larger programs have huge amounts of data stored. So the question is, do we really need a variable per element of data, per item of data that we need to store? And you can just imagine that gets really annoying. So look at this, right? So this is the number of ice creams I've eaten in a week. So I want a little program that will store for each day of the week, so 7 days, the number of ice creams I ate. And you can see on day 5, I went pretty hard at Messina. So if we look at this program, I'm going to make this just a bit bigger for me. That's better. If we look at this program, you can see I've got 7 lines of code just for creating some variables, and they're all the same data type. They're all very repetitive. This doesn't really seem right. As a programmer, when you look at a program like this, a red flag should be triggering because it just seems very repetitive. And then if I've got to look at that every day of the week, I got to if day 1, if day 2, if day 3. This is going to be like a 60-line program to do something really simple. And so when we see programs like this, something should be firing that says that maybe this isn't the most efficient thing we can do. But we have no building blocks to do anything else at the moment. So these variables clutter the program. And this is just 7, right? Imagine if you've got 100. What if it was days of the year? 300. That's 365 variables. Is that 365 lines of code? That doesn't really make sense. It's not efficient. right? Is that making sense? Like, I've written programs that store thousands of items of data. Do I need that? Like, I don't want, it doesn't scale, right? Is what I'm trying to say. So the solution to this problem, and it's a very early problem that had a very early solution, right? This is like a day one stuff of language design, is that we need data structures. We need a way to group like elements in a particular data structure. So there's many types of data structures. But there's a few that are really common building blocks of every other data structure, and so they're the two that we're going to look at today. So data structures are structures used to store multiples of data. Okay, let's actually think about that line. So we're not saying there's nothing to do with structs here. Structs are a different type of structure. They're structures to store multiples of data. So there are just cases where we need to store many of the same type of thing. And in COMP1511 especially, these usually mean we're storing the same data type. So in that example of days of the week, they're all storing, let's go back to it, they're all storing an integer. Do you see that? So typically a data structure would be storing multiples of an int in this case. And the really great thing is that they scale. So we can store 10 ints, 100 ints, 1,000 ints, 10,000 ints, or doubles or characters or whatever it might be. These data structures allow us to scale from a few elements to many thousands and more, in some case millions. Although once you get to the really top end, then you have to do some clever tricks. So we're introducing a data structure today called arrays. Okay, it is the most fundamental data structure you will ever use in your programming career. The second hurdle and the structure we'll look at in the future is the linked list, which is a lot more complex to use, but very powerful in a different way. I can see my camera is just covering that a little bit, so I'll make it small. These are both very powerful and drive many other data structures. You will use them for the rest of your programming career. So let's introduce the arrays data structure. And there's some terms here that you may have never heard of, or maybe you have heard of them, but we're going to cover them. Let me just look at the chat really quickly. So why not use enums? Enums are not a data structure really. So enums let us just have a single element of the enumerated set be active, right? So I can have, it's just like limiting your potential set of values. So like days of the week is a good example. So you could have Monday through Sunday as your full set of enums. And if I create a variable of that days of the week enum, I can have a single Tuesday, for example. It doesn't let us say that each element of the enum has an associated integer. So enums wouldn't solve this problem for us. Enum stores, enum is just like having a single integer. Like it doesn't help us store a multiple of anything. Okay. All right, so back to arrays, back to the lecture slides. So an array lets us store a collection of data. It's exactly like in our ice cream program, we could store 7, elements of the number of ice creams I had each day. And there's a limitation in C that they all have to be the same type. And the term for this is homogeneous. So we can have an array of integers, or we can have a different array of doubles, or a different array of enums. But for a particular array, every element has to be the same type, right? It's just a limitation of how arrays are built in C. We have a single identifier for an entire array. This is really important. So we don't have, if we have an array that stores 10 elements, we don't have 10 variables. We don't have 10 labels. We have one variable, one label that can store 10 elements, or 100 elements, or 1,000 elements, right? So this is great because we get a single piece of a single label that we can throw around our program that refers to the entire sequence of data. Okay, and this is also really important at this point. It's a random access data structure. Now, this is just a fancy way of saying that the performance cost for accessing the first element versus the middle element versus the last element is static. So I can randomly access an element in any position of the array for the same performance cost. So this is really important. We'll talk more about performance and optimization later on. But so this is exactly like RAM, for example. The RAM in your computer is random access memory. And so it's a fancy way of saying that the time to access any particular point in RAM is the same, more or less, and it's the same for a random access data structure. So linked lists are an example of a data structure that are not random access. And absolutely, Brianna's right, with the double typo. You will learn much, much more about this stuff in COMP1511. Okay. So that should say we can read or modify individual elements, and it's contiguous. So what does this mean? So even though we have a single label or a single variable for the entire array, we can access and read and write to any individual element. That sort of makes sense. And it's contiguous. What does that mean? What does anyone know what the word means? Just from general English, if you're not familiar with it from a programming sense, you can post that in the chat, right? It's one of those words that's kind of useful to know once you know it. So contiguous. So here's a visualization of an array. And in this case, I've said my array element can store 5 elements. So it's got room for 5, whatever the data type might be. In this case, let's just say it's integers. All that contiguous means, and Almanyoyo anyway, is correct. It means they're next to each other. So it literally means in memory, right, in the RAM of your computer, if I create an array, it's physically next to it. Each element is physically next to each other. This is really important. Without this fact, arrays wouldn't be random access. So in this example of 5 integers, I know that the size of the array is going to be 5 times the amount of storage required to store a single integer. So in this example, this array is 160 bits of memory. It's just 5 times 32. So an integer is 32 bits. On most architectures, I've got 5 elements, therefore it's 160 bits of memory. So when I create an array of 5 integers, okay, I'm asking the operating system to give me a block of 160 bits of memory. That's why it's contiguous. So the operating system doesn't really know that or care that I want a 5-element int array. It's just me asking for 160 bits of memory, all packed next to each other in RAM. Oh, that's a cool example, Sinai. In countries, it means that they share borders, right? So yeah, if 2 countries share a border, they're contiguous. It's a single block of land. Exactly the same thing here. So I ask for the operating system for n, the size of my array, multiplied by the size of the data type. So maybe I will move this up here. So here's a different example, and here's the syntax for declaring an int array. So you can see, like, it's really similar to creating an int variable. So I have the data type of the variable. So in this case, integers. I have the name, ice cream per day. And here's the new part. All right, here's the new part. So this is an int array of 7 elements. So you have square. So again, in programmers, we love braces, right? So now we're introducing the square bracket. So when I have a variable declaration followed by a set of square brackets with an integer in it, this is saying, I want an array of 7 elements. So my question to you right now is, how many bits are we asking the operating system to assign for this piece of memory? And while you do that, I'm going to calculate it off screen. Yeah, exactly right. 7 times 32 bits is 224 bits. So we're asking the operating system for around 224 bits so that I can chuck some values into that piece of memory. And this is a visualization below it. And it's the way I visualize arrays. We have the indices, which we'll talk more about in a moment. And we have room for 7 integers down here. Okay? How are we going so far with this? Am I going too slow, too fast? Give me some feedback. The delay is really annoying. Oh, thank you. We got a poll. While you're answering that poll, I'm going to get some water. Okay. I'm back. How's the poll going? 78% were okay, a few saying we're too slow, a few saying we're too fast. All right, I guess that's life, right? You can't please everyone, but most of you are happy, so that's good. Let's continue. I'm going to end the poll. Okay. Good. All right, so how do we get data into an array? Like in this example, this creates the data for an array, but we're not putting any values into it, right? So how do we do that? There's a few ways. Let's look at one way, which is to declare and initialize all at the same time. So in this example, we're creating a 7-element int array, right? That's really important. Like you should be able to look at an array declaration like this and break down those components. 7 elements, int array called ice cream per day. They're the components of the array declaration. And here's how we can initialize an array at declaration time. So what you do is you say is assigned, right? That's like how we assign values to every program. 7 integers. So that's going to pack this array with 3, 2, 1, 2, 1, 3, 5. Right? So each element will be assigned the sequence of integers passed. Now, there's a big caveat here. You can only do this while you're creating the array. In fact, I've never actually heard the answer as to why you can't do this later on, but you can't create an array like this and then later assign it like this. You can only do this while you're declaring it. I don't know why. Maybe someone will tell me one day. Now, interestingly, there's a few sort of interesting things to note with this syntax. Like you can do this, and when you don't have any values in the curly braces, they're just assigned 0. So in this example, every element will be assigned 0. So some comments. So an array saves lines of code, but it's the same size as declaring each element individually. Paints, that is exactly correct. So the great thing about arrays is that there's no memory overheads than if you were to create the individual variables. So that's fantastic. And then Limes says, so you can't enter the values inside the array after it's been declared. That's not true. You can, you just can't assign them all at once using this syntax after it's declared. Yeah. Another fun fact, I don't know if I've got a slide on it, but I'll show you in the demo later. Let's say you've got a 7-element array, but you only know the first 3 values. You can do like 3, 2, 1, and then the rest will be 0. So that's just how this works if you don't have all the values. All right. So this is visualized with our little array visualization. So the indices are 0, 1, 2, 3, 4, 5, 6. We always start our indices at 0. This is important, and you'll see why this is important quite soon. And you can see when we declare and initialize this array, the values get assigned over to the elements in the array. So each element is just an integer, and the integer is stored in that particular piece of memory. Pretty straightforward, right? Okay. So this is how we can get elements into an array. The logical next question then is, well, how do we get them out? How do I read a particular element of an array once it's been assigned? And so we use the indices. So this is really, really important. So the indices being this index. So here in this line of code, let's assume I've created this array and I have this array. What I'm doing here is I'm saying, and it's a bit annoying that this is over 2 lines, but there's nothing I can really do about it. When we jump in the code, it'll look easier, look simpler. But so I've got this array called ice cream per day, and I can access now. Now this is different from creating. I can access the 0th element, or the element where the index is 0. So when the index is 0, what's the value? The value is 3, because that's the first element that was assigned to our array. And then what this line of code is doing, so is it's getting that element, so it's getting the value 3 and assigning it to a new integer called the first day's ice creams. So that's just an example of how we can read a value out and then do something with it. In this case, we're assigning it a value, but you could do anything. You could print it. You could do whatever you want. Okay, here's the trick, right? Here's the trick. This uses the same syntax to define the size of the array because we have the int keyword before it. Here, the array already exists, and so this is not defining the size of the array, but getting the 0th element. Okay? So if I'm defining the array, this signifies the size. If I already have the array, this signifies the index. So someone's asked, how can the computer tell? Oh my God, sorry, I know I'm getting hiccups. How can the computer tell? It's the same way we can tell. When there's a data type before the line, then it's the size because it's a declaration. Here there's no data type, right? There's no data type to the left. So that's getting the element. So exactly the same way that we can tell. So this will retrieve the value 3. All right. How do I change a particular element once I've got an array? And it's really simple. We use that same indices syntax, and then we just reassign a value to it, just like it's a normal variable, right? It's really cool and really simple. So we've just changed that 3 to now be a 5. 5 is assigned to the ice cream per day array at index 0. So we go to index 0 and we change it now to 5. And basically now that gives us the building blocks to do whatever we want. Do we want to jump to a quick demo? I think let's jump to a quick demo. So I'm going to come here. I'm going to go here. I'm going to go here. Let's make a new file called arraysintro.c. I'm going to just copy some of the boilerplate. Yeah, that looks okay. Let's clear this. All right, so let's actually do something. So again, let's create an integer array. Let's call it, now we did ice creams per week. What's another example? We can do temperature per week. Okay, now this creates a single int. That's not an array. In fact, I'm going to actually leave it. This creates elemente, it's Spanish. This creates, I want that to be temp, an array of 7 elements, right? Do you see the difference? So very, very similar syntax to creating just a single variable. All I do is add the square brackets with an integer, and that tells us how many elements is in that. That means there is 32 bits multiplied by 7 elements equals, whatever that is. What do we say? 224. Cool. And I could say this is equal to, it's pretty cold at the moment. So like, I don't know, 5 degrees, 10 degrees, 12 degrees, 6 degrees, whatever. I need 7, 1, 2, 3, 4, 5, 6, 7. And so this will create an array of 7 elements and assign those 2 values. And then I just want to show you something. So I can say printf %d \n. Okay, the temperature is. Now I can give it a particular element now. So how do I do that? And I want you guys to tell me. So how do I print? Let's say I want to print this day's temperature. So I want you to tell me what to type for the rest of this printf statement. All right, so what do we got here? Temp per week 4. Temp per day, 0. 3, 3, 4, 3, 4, 3, 3, 3, 3, 6, 3. So, what is it called? The wisdom of the crowd? The wisdom of the crowd is usually correct, and in this case, it is 3. But let's look at why it's not 4. So, the way to think of it is always, stop doing that, the indices. I wish it, oops, the indices. So this is the 0th element, this is the first element, this is the second element. 6 is the third element. Remember, it's when we program in C, we're 0 based. And so those of you who gave the syntax like this are spot on. The name of the array, square brackets, the index that I want to print, which will print 6. Don't forget your semicolon, come back here, compile this into a program called program. Oh yeah, this is just saying that I'm not using this variable here, so I'm just going to comment it out. I get no errors. I run this program. The temperature, I can't spell, but you get the idea. The temperature is 6. That's exactly what I wanted. So I randomly accessed, well, I didn't, I accessed index 3, which got me the value 6. Okay, what's the comment saying? Comment. You're just mostly putting in the line. 333. Would it not be 1 since Monday equals 0? Assuming start of the week is 0. Well, 0 is the element of 5, 1 is the value of 10. So we wanted this element, so it has to be 3. I don't quite get your comment though, Paints. Maybe Brianna can have a look at it. If you input less values than index, you will get zeros. Okay, that's okay. But what happens if you put more? Okay, that's actually a good question. I don't know. Maybe an error? Yeah, you get it. Well, you actually get a warning. But you shouldn't, don't do that. Looks like it tries to put the value in the memory. It could be an error, I imagine. Do unused variables affect performance because it requests memory? Absolutely. There'll be a memory cost for the declaration that's wasted because you never use it. You said we could scale to thousands, but wouldn't that result in a huge block of just values? Spot on, window. Spot on. But you could do it. That is a good question. Thought we were asking for the Tuesday value. No, I didn't say that. I just wanted whatever this one would be. So I guess like Monday, Tuesday, Wednesday, Thursday. All right. What day of the week is Monday? Don't worry about what days they actually are. Like this could be anything, right? Is it possible arrays and arrays? It is possible. We'll actually look at that later. All right. Okay, cool. I think everyone's doing okay, looks like. All right. Now, there's still kind of a problem. And I'm hoping that maybe some of you can spot the problem. Well, it's not a problem, but it's just that we introduced this idea of arrays, we said to save us lines of code. But if I look at this, right, doesn't this still look like I have the same problem? So like, I've got 7 elements here, 7 ice creams per day, or 7 temperatures per week, or whatever it is. But I still need a line of code per element. And so again, if we think about having a 1,000 element array, that's still like 1,000 lines of code. Do you guys see that? And you're like, Jake, the whole point of this was to save us lines of code. Yes? No? Maybe? So if we look at these lines of code though, you can see they're pretty similar. So this is like if I want to read each element of the sorry, I just saw Ashley's comment. The whole point is to save us. Exactly. If we look at these lines of code, so this is reading each element of the array. Let's say if I just want to print them, I would wrap each line in a printf statement, right? If you look at these, one character changes on each line, and it's that element, that index. 0, 1, 2, 3, 4, 5, 6. So does this look repetitive? Yes. And if only we had a mechanism that we could use to iterate, count, dare I say, loop through each element of the array. Do we have some way to do that? Who's got a gigabrain moment here? Can anyone suggest what I could do here? Yes, exactly. Wunther and window. We use a while loop. That's why while loops and arrays are best friends. See, look at that gentlemanly handshake here. And like, it's so great. Like, it's so good. In fact, it's so good, like, we're going to go straight into a demo program here. But let's actually start with the bad code. I'm going to make a new file called arrays loops.c. I'm going to just copy this. Wait, why don't I have a C format? Let's just install that. Yeah, I thought, I didn't install it in the SSH environment. Got it. Installing. Hopefully that works. Close that. Format. Is that going to just work? Yay. All right, good. Save that. All right, so main. We have our 7 elements of our ice creams per day. 3, 2, 1, 2, 1, 3, 5. This is just printing each element. Yeah? Read/print each element of the array. So I come back to my thing here. I change the program. Arrays, loops. Hopefully there's no error here. There's not. I run the program. And you can see each day gets printed. 3, 2, 1, 2, 1, 3, 5. 3, 2, 1, 2, 1, 3, 5. So this is an example of the bad way of doing this, because we have a line of code per element. Again, imagine if this was 700 elements, I would need 700 lines of code. And again, if we look at these lines, like look every character, every line is exactly the same except for the index value. So there's got to be a better way, and there is a better way. So this is bad, and this is good. And so what do? We loop. How do we loop? We make a counting variable called I, and we assign it to 0, right? We know how to do that. And we make a while loop. While I is less than, well, what should it be less than? It should be less than this 7, right? Because that's how many elements we have to print. So now I have a while loop. While I is less than 7. And what do I do in this while loop? Well, I decompose the repetitive code, okay, into the loop. But I can't print 0 here, right? Why can't I print 0? In fact, I'm going to do... What's the problem with it just being 0? Yeah, it's just every time it loops as my God, your YouTube names are crazy. Menocheha. I'm just going to go Ahmed. It's just printing the 0th element each time, and the 0th element is 3. So what should this be replaced with? You know, I can't put a number here. It's always going to print the same value. But what variable do I have that represents the counting? And you're all spot on. It's I. I is a variable that counts. And how do I know that? Well, let's just print it out. %d. I is %d, comma, I. And let's put a \n there. Isn't this cool? I mean, this is so cool, I think. So here, now, in the cool way, I'll get rid of this eventually, but I is 0, which is 3. I is 1, which is 2. I is 2, which is 1. I is 3, which is 2. Oh, and it goes all the way to 6. Eventually, I will become 7. 7 is not less than 7, so the loop fails and we finish the program. You know, this is amazing because 70, 700, I change one index here and it just scales up. Whereas here, it doesn't scale. So this is really powerful. I can get rid of this line. And you can see now that they're printing the same values. So this is what I would call a pattern. Using loops with arrays is a very powerful pattern. I agree, it's very cool. Is this why we use while loops and not for loops? You could use a for loop to do this, by the way. It's not really why. We just pick one loop. Everything you can do in a for loop, you can do in a while loop. So we just stick with the while loops most of the time. Yeah, you guys are doing great. So you've if you can reason about this, you're in a really good spot. Okay, Sushi, that's a really good question. What happens if we try and call an index past the length of the array? So, aka, what if I accidentally put an 8 here, but I still only have 7 elements? Well, we find out. We try it. And then we discuss. Actually, so this is interesting. So if you tried this with a normal C compiler, this would have compiled without a problem, probably. But DCC is really smart, and it's actually syntactically spotting this problem. However, this is just a warning. It's actually valid C, so we can still run the program. But the DCC compiler is trying to help you out here. But if I run this, we get an error. So this is a particularly nasty error. It's called a runtime error. And you can see that you do get a really helpful description here, but we're accessing an element outside of the range of our array. So it's an error. It's actually very interesting and good to talk about. But basically, what the problem is, when you ask for something like an array or any variable, any memory, the operating system carves out the memory for you and gives it to you. If you try and read memory outside of what you've been allocated, the operating system will kill your program. And that's what's happened here. So in this case, macOS killed my program because it thought I was trying to read memory. Well, in fact, I was trying to read memory that I wasn't allowed to read. You got to understand why this is such a big problem, because if I could read memory that I wasn't allocated, I could write a C program like this, and I could read the memory stored by your banking application and read your credit card number. Like, you could do really terrible things. So the operating system is very strict and responsible for shutting you down. But good question. So if we want to loop 100 times, we just need to change the 100 with 100 different elements, and then that's exactly right. That's exactly right. We could make it even smarter. So we can say hash define num elements to 10, and I just replace this 7 with num elements. And that way, I'll never have this off by 1 problem, because I'm just sticking to the number of elements. And if I think about this, this is really cool, because this also lets me demonstrate what happens when you don't have enough elements here. Like, this is such a cool way to do this, because so I've increased the number of elements to 10 by making a hash define. This lets us show off a number of things. First of all, it shows off that if I was using the bad method, I'd have to add 4 more lines of code. But with the good method, I don't have to do anything. So I recompile. There's no error. I run the program. And look at this. The bad way stops at the 6 or 7 elements. The cool way prints all 10. And I get the zeros here because, like I said earlier in the slides, when you use this syntax and you don't give it all the elements, the rest get filled with zeros. So this is a really good way to use this pattern. Yeah, cool. Very cool. Whoop. Okay, so we already jumped into a demo. I think it's time for a Kahoot. Or do you want to break first and then Kahoot, or Kahoot then break? I'll leave it here maybe. I have Kahoot PTSD. What, you can do whatever you want. What was the reason that caused DCC compilation failure? Let's find out. I think it was when I accessed beyond the number of elements. So basically the problem is, I can show you the problem a lot more simply. This is my array with 10 elements because it's num elements sized. Yeah? So if I access the 11th element, even if I access the 10th element, This is going to cause an error. Why? Because I've only got up to index 9, because it's 0 through 9 is 10 elements. So this is going to error. This will error. I am accessing data outside the length of my array. Does that make sense? You can see I'm getting that warning already, but if I just run the program, I will get the crash. So I can't access data elements that I don't have permission to access. Does an array automatically set elements with value 0 as default? If so, is it redundant to give an empty curly brackets when defining an array? Good question. The answer is actually no. In the specification for C, if I just do this, this does not zero out elements in C. So this will actually just leave the... So you carve out the... You ask the operating system for the memory. You carve out the piece of memory. You get back the memory. Whatever garbage data was already in there just stays in there. So you can imagine that it's a bit of a problem. So you should always, even if you just want it to be zeroed out, do this. However, DCC zeroes out the values for you. So our particular compiler actually breaks C convention and zeroes it out. But that you should do this, and I should undo and go back to the elements. Whoops, there we go. Okay, break has won. So let's go on a 5-minute break. Come back, Kahoot, more demos. And I'll respond to chat questions in the chat. Cool. I'll see you in a sec. 5 minutes. I'm gonna start a timer. So because people tell me 5-minute timer. There we go. I've got a timer going. I'll see you in 5 minutes. It's not like a Python array. No. Okay. The timer's going off, everyone. That's 5 minutes. Don't at me that the breaks aren't the right time. I read that in the feedback too. Yeah. Okay. I'm just kidding. All right. I have to get. How do I do this? I guess I can just do this. Do this. Google Chrome. Do this. I might do. Oh god, streaming is hard. Streaming is really hard. How's that? Alright, make it. Oh no, I can't make it full screen. Anyway, copy the link. I'll put this in the lecture chat. Oh, I can just link it. That's really good. What's that do? No, that's not what I want. That's fine. I might just disable my webcam in case it covers anything up. People are joining. You can even hear the Kahoot music, I think. I can't hear it, but that should be fine. Okay, you're going to make a big picture of my face using C with nested while loops. Oh my god, good luck. My sandwich isn't ready. Limes, you had 5 minutes. I'm just kidding. How long do you need to make your sandwich? Make your sandwich, and then we need to give people time to join the Kahoot anyway. So maybe breaks should be 10 minutes. Ugh. How was your day, Jake? My day is good. I got up, I had a coffee, then I had like a second coffee, and then I thought about having a coffee right now, but I'm like, that's probably too much coffee before 12 p.m. I'm gonna have a, coffee-induced anxiety attack. But that's how things go. Clash Royale. I don't know what that is. We can try it another time. How many people are in here? 80. And how many people are in the stream? 143. Guys, what are you doing? Join the Kahoot. I guess you don't have to. You can do whatever you want. Are we good to go? Does anyone need a minute? And I also read feedback that I went through the Kahoot too quickly. So I'll give you... You're making your sandwiches. How many of you are making sandwiches? That's very healthy. It's very good though. I'm very proud of you. That's very good. Have you made your sandwiches? Are you ready for the Kahoot? How many do we have now? 86. We're climbing still. Let's feed Jake a sandwich using C. Okay, be careful. Be careful. Halfway through your sandwich. Guys. You're eating it or making it? Anyway, I'm going to start the Kahoot. Are we ready to start the Kahoot? Those of us have 3 hours of comp. I mean, fair enough. Fair enough. You're still making it. What are you guys making? Like, how fancy are these sandwiches? All right. Am I okay to start? I'm going to start. We hit 93. I feel like I'm going to start. I'm going to start. Oh my God. Why is that gone full screen? Exit full screen. Okay. Week 3, lecture 2, functions. Let's go. Okay. Functions help us do what? Group-related instructions. Reduce the amount of code we need to write. Can compute a result and return it to the caller? Or all of the above? What would the answer be? Okay, very good. Yeah. You can reduce the amount of code for sure. You can compute return result. That's what a function does. And you can group related instructions within a function block. Very good. It's black. What does that mean? Anyway, and most of you smashed that. So very good. Very good. You're first. Good job. Okay. Second question, true or false? Functions always do exactly the same thing. I like it when these simple, fun Kahoot questions get like philosophical. Is it doing the same thing? Is it not doing the same thing? You guys all colorblind? Not that that's a problem. 8% of men are colorblind. Did you know that? Don't at me. Okay, oh my god. That's a brutal question. 50% down the middle, almost exactly. Yeah, I would say the answer is false. I agree. Why is the answer false? Functions do not always do the exact same thing. Why? Can someone, instead of just going nuts in the chat, can someone explain why? If you run the program so many times, it still follows the same lines of code. That's not quite true. We've already talked about if statements. So if statements let us control the flow of a program, and depending on state, depending on the value of a variable, what the user does, different lines of code can run. And so because functions can have input, that means not all functions do the same thing, because depending on the input of a function, you might do different things. So because you've got different inputs, you might have different outputs. If you've got different outputs, the function is not doing the same thing. But you can imagine a function with... Oh, you can't see my webcam. Is it safe to put the webcam here? I think it's okay. I'll keep an eye on it. So if a function has... What am I doing? If a function has if statements in it with a different input, then the function will do something different depending on what's passed in. But you can also just like, even without input, right? Even if you've got no input into a function, you can do things like generate a random number and just do something 50% of the time, or do something in different, 10% of different cases. So functions do not always do the same things. But this is good. Now you've learned something. Ooh, still on top. Okay, true or false? We need to import a library to use functions in C. Okay, this is interesting. So remember importing libraries? That's when we do hash include, like for example, standard IO. That's importing a library. So the question is, do we need to import libraries, or is there a particular library we need to import in order to use functions in C? Oh no, I clicked the wrong one. Yeah, that must hurt. Bad luck. Yeah. Oh, guys. No, the answer's false. You do not need standard IO to write a function. Yeah, Wintho is definitely, you got to stop listening to chat. You guys need to do. So standard IO is only needed for input output or printf scanf. So it is not needed to create functions. Functions are not part of a standard library. They're part of the C language itself. You can test this yourself. You're like, oh, I don't believe Jake. You can remove hash include standard IO. You can create functions. You just can't print though. The problem is you can't printf. So yeah, printf is input output standard IO, but nothing for creating functions. Does that make sense? Oh, that was brutal. Good job, excited yak. All right, we have 9 questions today. Okay, to call a function called fun in C, that requires 2 inputs, which are integers. How would you define that? This is a good question. Oh God, the timer is pretty short on this. Yeah, you guys got wrecked. Yeah, you're cooked. What's the question? To call a function. To call a function, not to define it. So if you've put yellow, you're correct for defining it. To call a function, you just call the name and then parentheses and then the values. So you guys got absolutely slammed. The 9 of you that got it right, good job. Yeah, I guess you all wanted the solution now, didn't you? Do we need to talk about it? So a few of you put red. I think you just forgot the int, but you also thought you were defining it. So all of you thought you were defining it. Because, okay, so why is red wrong? If you're just calling a function, you don't give the data types of the variables. When you've got data type and, you can't say when you've got data type and value, that creates the variable. So that this wouldn't work for calling it. This is correct for calling it. This is just 2 data types, so that doesn't work at all ever. And this is correct to define the function, but not to call it. So this is correct. So the 9 of you that got this, I don't know, maybe some of you just misclicked, or some of you maybe actually understood the question. But you got to read the questions correctly. Yeah, that was brutal. All right, question 5. What parameters go in the 2 question mark spots on line 1? Okay, this I believe you guys can do. Maybe. I don't know. Depends how good you are. Yay, that's it. That's it. That makes me happy. When we call this mystery function, we're passing in an integer called a, then we're passing in a double called b. Therefore, it should be int something, double something. The only int double is yellow, int a double b. The names don't really matter. What matters are the types. So, yeah, well done. Wunther just giving everyone the answers for some reason. Interesting strategy. Maybe he's going to switch it up, give the incorrect answer next time, and then you're screwed. Okay, Aquatic Badger on top, Clever Sloth, Creative Lion. Well done to the podium. We have a few questions left. Which data type is returned by the function mystery? This also doesn't look too bad. Integer. Oh yeah, of course. Why is it integer? It says it here. Int. Now, remember, characters are just integers, so this will return the ASCII integer for the character Z, but the function itself is definitely returning it as an integer. So you just look at the return type there in that case. So blue is the correct answer. If you did red, you looked at the value here, but not the return type. So sometimes there's a mismatch. Some data types are like compatible, and characters and ints are one of them. But it was returning an int. But Aquatic Badger stays on top. All right, 3 questions left. What is a function prototype in C? We spoke about this a lot yesterday. So let's have a look at these. The definition of a function's implementation, a declaration of a function providing info about the name, return, and inputs, a function that is called from within another function, a function that does not return a value. Of course. It's like... Okay. Yeah. Very good. So the function prototype is just like the signature of a function. It gives you the information about its name, the return type, and the types of the inputs and the sequence of the inputs. So blue is the correct answer. Oh my God, I'm dying. It's not green, a function that does not return a value. That's not a function prototype. And then, yeah, not many people did red or yellow. If you've got questions about these answers, please put them in the chat. Yeah, good. Wunther, put your answer in after the question's due. That's probably better. All right, Q8. What is printed out on line 12? Line 12. I'm going to have a look at this. Line 12. Yeah, I was expecting that to be a bit brutal. Although a lot of you got it. A lot of you got it. Okay, what's going on here? I mean, this is, attention to detail. So here's how I would do something like this. Like, here's how I think about it. I start at main. Like, main is where the program starts. That's where I'm going to start. Why start up here at sum when you don't even know if sum's going to be called? In this case, it does get called, but why start there? So let's start at main. X is equal to 3, int y is equal to 7. So we have two variables, two integers, x and y, 3 and 7. Int result is assigned the value of 0. All right. So that's pretty straightforward. We call the function sum xy. So sum is a function that returns an integer, passes to integer, and it calculates the result of summing the two values and returns it. However, the problem is, and maybe most of you have spotted it now, sum is not assigned to result. So we do calculate 7 plus 3 is 10, and then we do nothing with the return value, we throw it away. So when we get to our print statement, we're printing int plus int is int, x, y result. So 3 plus 7 is 0 because the result was never reassigned. So it should be 3 plus 7 is 0. Cool. Lime's finished their sandwich. I want to see these sandwiches. We need a sandwich chat on the forum. It's too fast for me to figure out what's going on. I'm a bit slow. Yeah, I think the time is a bit slow, a bit fast on this. But you can remember, don't watch the stream. Watch the Kahoot on your thing. Otherwise, it's too slow. But the function mystery is the end of the main function. What? The function mystery? What? I don't know what you mean. Sorry, Carson. Why do we have result assigned to x plus y in the function? Okay, the function assigns, that's it. So remember, when a function has all functions have a set of curly braces, which means the variables within the function are local. Remember we were talking about scope yesterday? So this result is a different variable than this result. That's really important. So they're not the same variable. It's in a different scope. This really, I notice this throws a lot of people off in this course. Scope, variables and scopes and things. This is a different result. There's no overlap. Yeah, cool. So that's really important to learn. All right, we've got aquatic badger still on top. Last question. What is printed out on line 10? Yeah, it's 24. I know it's not a lot of time, so it becomes a bit of a race, but we got to be competitive. All right, what the hell is going on here? Again, I think the problem with this is around local variable scopes. So let me run through it really quickly with you guys. In main, x is 5, y is 6. Okay, that's pretty straightforward. We print out a single integer, which is the result of calling the something function, passing in x and y. So we pass in 5 and we pass in 6, okay? Remember, when we call a function and pass in arguments from variables, we are not passing the variable, all right? We're passing the value stored at the variable. We do not pass x, we pass 5, okay? So 5 and 6 get passed to x and y. The first line of the something function reassigns x to 4. So whatever x was down here and whatever gets passed in doesn't matter. So we have 4, x is 4, y is 6 because it doesn't get reassigned. So we have 4 and 6. Int z equals x times y, or x is 4, y is 6, 6 4s are 24, and we return 24. So 24 comes back. 24. Yeah. Speed. If speed's a problem, that's fine, right? Because, all right, podium. Clever Sloth on top. Well done. sorry, on third, but still well done. Creative Lion and coming in second. And in top place, we got Aquatic Badger. So if you podiumed, screenshot your podium right now, send it to me or send it to someone on the forum, and you can come get your Pokemon card after next week's Monday lecture. Yeah, who are you? Post your names in chat. Or maybe you don't want to post your names. You don't have to, but if it was you, screenshot it and show me next Monday. Yeah, GG. Well done. Okay, I think that was a good Kahoot. We learned a lot there. We learned a lot. So this needs to go back to slides. I present a presentation. Okay. Very good. Very good. All right. What we're going to do for the rest of the lecture, which is about 20 minutes, is to expand the demo. All right. Expand the demo. So there's a few things I really want us to talk about. Can I zoom out one time? Can you tell me if that's still legible? And I might just shrink this a bit. Still legible. Good. All right. I'm going to leave these two files. I'm going to make a program called array-demo.c. In this array demo, I'm going to just copy this into it for now. I'm going to delete all of this. Okay. Cool. All right. We're going to do something a bit more. What are we going to do? Okay. So what I want to do in my program is maybe put this up here. A program which reads from the user into an array and prints the results out using loops. So we're going to combine reading and writing using loops to a single array. That's basically what we want to do. And if you've got any ideas and questions for the theme of the program, just type them in the chat. So we always want standard IO. We can leave that there. No, that should come under, right? And we want, we can think about what this is, but we will want a constant here for the size of the array. We got the main function. Now, what do we actually want to store here? Ice creams per day. Why don't we do our temperatures again? So weekly temps. And because it's weekly, then this is going to come back to 7. Okay, actually, I like that. Let's do sandwiches made per lecture. I like that. All right. Now, do I know how many sandwiches have been made in each lecture? I don't know. I'm going to have to scan them in. So I'm going to just zero out my array. This is called zeroing out my array because when I have an empty set of curly braces, each element will be filled with a 0. This is good practice. I've heard you say boilerplate sometimes. What does this mean? Boilerplate is like the stuff that every program has. So like this is boilerplate, and this is boilerplate. Like it's just the boilerplate, you know. This is the boilerplate of a program, of a C program. It's what you need to start every C program. Okay. So we zero out an array here. Oh yeah, I got a cool idea. All right, so we zero out my array here. Sandwiches made per lecture. we have 7 elements. This is assigned to a constant. This is really important because it means that I never have to remember how many elements are in my array, and I can change it really easily. All right, so the way this program is going to work is I first, why does it do that? I hate that. First, read in the ints in a loop. So I need to loop over every element in this array and scan a number in from the user. So how do I do this? Well, I'm going to ask you guys, how do I get started with this? So I don't just want to say, sandwiches made per lecture 0, then 1, then 2. Like remember, this is not the right way to do things. So how do I get started? By using a loop. By making a counting integer I using loops. Absolutely correct. And this is also another example of boilerplate. Anytime we need to write some code that is that is repeated, right? This is boilerplate. All right, what should the loop condition be? It's not while I is less than 0. That would never loop. What should it be? It is 7, emu, but I'm not going to put 7 or 10. What am I going to actually type here? Yes, num elements, this. Because this will be mapped over to 7. So this will be 7. So it's going to loop 7 times. Yep. Very good. So remember to use your constants. It means you'll never have a runtime error because you used it to create the variable. All right. So this is our looping boilerplate. What are we going to do every time the loop runs? We want to scan in to the particular element. So I'm going to do a printf statement for my prompt first. So enter day. I'm going to do %d. You'll see what I'm doing here. Daisy sandwiches. Like that. So enter day blanks sandwiches, and I'm going to pass in I. Actually, I'm going to pass in I plus 1. So 0 will be 1, 1 will be 2, 2 will be 3. I always need my I plus plus at the end. And then what do you think I'm going to put here? Okay, window soup. Should we make a variable for the scanned element? No, let's not do that. What else could we do? I've already got my array, right? So how can we just scan in straight to the array? And if you're not 100% sure, but you just want to take a guess, just take a guess. All right, so sandwiches made per lecture, brackets 0. Okay, you're not right because you've got the 0 there, and 0 will always read into the first element. But I want to see the scanf code. So Windows Soup has got something here. Okay, and that's so funny. So Windows Soup and Ben have done almost the exact same thing, except one of you has the ampersand and one of you doesn't. So what do we have here? So, but you're right. So we want to scanf a %d, an integer, into the sandwich made per lecture at index I, because I will be updated each time the loop runs. We don't forget our semicolon. We don't say, so Emu's daddy said, which is a crazy name, but whatever. Emu's daddy said this. This is not right because scanf does not return the value scanned. It scans into the variable. Now, if you remember, when we scan into a normal integer, we have to put an ampersand at the front. So the question is, do we have to do this for arrays? And the answer is, I don't think we do. And now I'm starting to forget. So let's actually just test this. Okay. I think this will work. So DCC arrays demo dash out to program. Yeah, okay, so we do need to. It's exactly the same. So it's exactly the same as if it's a normal integer variable. Cool. I run program. The loop's going to run. Enter day 1 sandwich. Like, this is really cool because we use our I index variable in the prompt itself to really help the user understand what's going on. Let's actually call it like week one's lecture. Anyway, look, like this will just assume we have like 1 lecture per week. Oops. So recompile the program, run the program, enter week 1. Okay, so how many sandwiches do we think were made in week 1 during the lectures? Like, I don't know, how many people made a sandwich today? Are you really all making sandwiches? Let's do a quick little... So that's 3. Okay, do a poll. 4, 5, 6. Are you really making 2 sandwiches per lecture? I don't understand students anymore. 7. I'm ignoring the 100. 8. Yeah, fine. Let's just say if you've got a sandwich, it counts. 8. It's about half down. I don't know what that means. Oh, you've finished half your sandwich. You did not make 10 sandwiches. But look, okay, it was 1. 9. So there's 150 of you. So 9 divide 150 times 100 is 6%. So 6% of you make a sandwich. There's 1,000 students in the course. So let's call it 60 sandwiches. So 60. Then in week 2, there was 60. Week 3, there was 60. Week 4, there was 60. Week 5, there was 60. Week 6, there was 60. Week 7, there was 60. All right. So that's working. Well, we don't know that it's working. We're not printing out. Okay, there's a poll, so we can get more scientific. So I think that's working. We're not printing anything out, so it's hard to tell. So what we can do here is actually print them back out. So we make a new while loop. I don't need a new I actually. I can just reset I. Print out the sandwiches made. So while that stays the same, we don't scan, but we print. So we can say week 1 %d sandwiches. I go I plus 1, and then here I put sandwiches made per lecture I. Genghis Khan. Interesting. Tough crowd, I suppose. All right. Let's compile that. Let's run it. So we said about 60, 60, 60, 60, 60, 60, 60. So we got week 1, 60 sandwiches. Okay, I forgot to do a \n, I suppose. Let's do that and let's rerun it. But it looks like it's working. What did we get for the chat? 60, 60, 60, 60, 60, 60, 60. Okay, week 1, 60 sandwiches, 2 60s. Okay, I mean, that's working really great. We're using a loop to scan. We're using a loop to print. Okay, it looks like 30% of you make a sandwich. 30% of you have a sandwich? That seems high. Anyway. All right. That's a lot of sandwiches. Big sandwich lecture. So we have scanning into an array, printing from an array. Now, what else can we do? I want to show you some other things. Okay, chat's getting a bit strange, but we persevere. So let's loop through again. And instead with this loop, we're going to average out the number of sandwiches eaten. So this is something really common that we like to do. So we're not going to print the sandwiches made each time, but we do probably want this. So how do we average out the number of sandwiches? Well, that every time the loop runs, or how do we average anything out, right? So to average, we sum, then divide by n. So I can make a sum, assign it to 0. Okay. I can say int sum is equal to the number of sandwiches eaten in that week's lectures. All right. So remember the plus equals operator is, oh, that's not int sum, it's just sum. The plus equals operator is whatever was in the value added to the expression on the right. So this sum, and then what I can do is print f sum just to show you. All right, so let's just say like 10, 20, 30, 40, 50, 60, 70, and then the sum is 10, then 30, then 60, then 100, 150, 210, 280. So it's just summing up the 10, 20, 30, 40, 50, 60, 70, right? So this is really cool. So at this point, sum is equal to total sandwiches eaten. So then once the loop is finished, how do I get the average number of sandwiches eaten? Okay, we're just talking about food now. Come on, guys. There's not even 10. There's 7 minutes left. So we can actually get some stats. So how do I get the average? Oh my god, that's annoying. Divide sum by I, divide sum by num elements. Interesting that you're saying to use I. I agree num elements is better. We don't necessarily guarantee that I will be the correct value, but num elements will be. But very good. So I can say int average sandwiches is assigned to the sum divided by the number of elements. Then I can print f average sandwiches eaten is equal to %d \n, comma, and I can just put average. Oh, that shouldn't. Okay, I made a problem myself here. What have I done wrong? Yes, YouTube account has got it there. It should be a double, not an int. Double integer doesn't really make sense for an average. Okay, that's the average, and then I could do something like the total sandwiches eaten is going to be, this will be a double, and then this will just be the sum, right? If you can think of any other stats, I spelled sandwich wrong. Oh yeah, there's no H. Oh my god, I've really spelled it wrong everywhere. There we go. Yeah, at least I was consistent. Yeah, that's exactly right. Well, I fixed it. All right, so we got the average, we got the total. Is there anything else we can do? Sandwiches eaten on a day starting with T. What's the fastest way to write this one? Okay, well, let me do this first, and then I'll see how good I am. All right, does this even compile? Yes. So let's just go. Let's just say there was 10, then 20, then 10, then 20, then 10, then 30, then 10. Okay, so the sum. Oh, let's delete this sum. That's annoying. So 10, then 20, then 10, then 20, then 10, then 20, then 30. All right, so we got 10 sandwiches, 20, 10, 20, 10, 20, 30. The average sandwiches eaten is 17, right? That's just the result of summing these all up and dividing it by 7. The total sandwiches eaten is 120. Cool. This is really cool. This is really cool. So we just have a few loops to do a few calculations. We're looping to scan, we're looping to print, and we're looping to do some aggregated statistics. So this is the three really, really common patterns with arrays and loops. Does the spelling for variables matter in the style guide? No. In that case, like, this isn't a problem. Like, I just don't know how to spell a word, I suppose. So that's not a problem at all. The style guide doesn't ping you on the spelling of words. All right, sandwiches eaten on days starting with T. God, how would I do this? There's probably lots of ways to do this. I could do something like this. Int count sandwich. Int should count sandwich is going to have an int array of 7. And it's going to be, so Monday, let's say the day starts on Monday. So Monday would be 0. Tuesday would be 1. Then Wednesday, then Thursday, then Friday, then Saturday, then Sunday. Okay. So this is like a mask. This is just for fun now. We've got 3 minutes left, all right? But this is just like one way we could do it. There's probably so many other ways we could do it. So I have a different way. Okay, that shouldn't be 7. We can also make that number of elements, so that way it matches. Should count is going to be assigned 1 or true on days that start with 2, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, so that's correct. Then we can come down here. I can create a new int t day sum is equal to 0. In my loop here, I can say if t day sum bracket I is equal to 1, then t day, that's not t day sum, that should count sandwich. Then t day sum is plus equal to should count sandwich of I. And then what did you want to know? You wanted to know just the count of it? Well, then that's it. On T days. There we go. So if I compile this program, I've made a typo. Thank you, compiler. Oops, I didn't compile. All right. So Monday, let's just say I ate. Well, okay, before I finish this program, what do we expect it's going to be? If it's 10 sandwiches a day, there's 2 days that end on sandwiches. There should be 20 sandwiches eaten on 2 days. 2? Oh, I'm just counting. Okay, there's a bug there. I'm only adding the flag. It should add the sandwiches made in the lecture. All right, so let's do it again. 10, 10, 10, 10, 10, 10, 10. There we go. 20 sandwiches eaten on T days. What a cool solution. Do you like that? Who asked that? Ben. Ben, I hope you're happy. All right. That's the lecture, everyone. Of course, very important to me. Please give me some feedback. I'll read it. I'll get sad when a few of you are rude, but that's okay. We persevere. We live on. But I do read it, and it is important. So please do give the feedback. I'm kidding, by the way. Yeah. Anyway, thank you. I really enjoyed that lecture. The chat was a bit weird at times, but keep being you. Keep eating your sandwiches. It's, I want you all to be healthy. So if you're making sandwiches, I'm really happy. Better than eating KFC or whatever. Why don't I do this? Here's my favorite sandwich shop in Sydney. They're pretty good if you live in the eastern suburbs. And then you go, and if you got a car, you go to Cutlinch Deli, and then you drive down to like Maroubra Beach or any beach around there, and you just eat your sandwich at the beach. But they're probably not as healthy. Anyway, Make your own sandwiches. That's good. Yeah, like, subscribe, and eat a sandwich, I suppose. All right, I will see you next Monday in person. Please keep coming to the lecture. We only do the online lecture on Tuesday so that it's more convincing to get everyone in on campus on Mondays. So I hope to see you all on Monday. By the way, if you want I've got a few potential guest lecturers teed up. If you like the idea of that, let me know. There's a big if though. If I bring on a guest lecturer, you must fill the lecture theatre. So if you're keen for that, let me know. All right, I'll see you next week, everyone. You'll be the guest lecturer? Okay. Well, sure. You pitch me your idea. You guys have a great day too. Bye.